Hello, myself and Pranit Kumar Reddy. Now I'm going to talk about software reuse. The main points we are going to discuss are introduction about software reuse, purpose of reuse in software, levels of software reuse, and approaches that support software reuse. Introduction. Software reuse is the process of implementing or updating software systems using existing software components. To achieve better software quality more quickly and with lower costs, software engineers are beginning to adopt systematic reuse as a design process. Reusable software assets can range from code libraries and framework to pre-built modules and templates. Software reuse is use of existing software or software knowledge to build a new software for an individual or an organization. It is also called as code reuse. Systematic software reuse is most promising and performing strategy for increasing productivity and improving the quality in software industry. It involves repurposing of code, design patterns, and even entire applications to save time and resources. Purpose of software reuse. The major purposes of using the software reuse are: first thing, improved quality. Reused components have often undergone extensive testing and debugging, making them more reliable and less prone to errors. This leads to higher software quality and increased customer satisfaction. Next, focus on innovation. By reusing common functionalities, developers can allocate more time and resources to innovate and create unique products and features that differentiate their software components from competitors. Resource optimization. Reusing the software assets minimizes the need for redundant development efforts, save both time and financial resources. This is particularly important for resource constrained projects. Next, risk mitigation. Utilizing well-tested reusable components reduces project risks. Known issues have already been addressed, making it less likely to offer critical bugs to emerge during the development. And lastly, enhanced flexibility. Reusable components can be adapted and extended to meet evolving requirements, offering a flexible foundation for future development and scalability. Levels of software reuse. The important levels of software reuse are reuse of ideas, reuse of domain knowledge, and reuse of components. In reuse of ideas, the specifications, designs, methods, techniques, and frameworks that are previously used in the building of software can be reused. Frameworks provide a structured foundation for application development. Developers build upon these frameworks, saving substantial development time. Next, reuse of domain knowledge. In reuse of domain knowledge, the documentations, plans, analysis data, test data, and maintenance data can be reused. This level further goes into microservices. Microservices are small, independently deployable services that work together to create applications. They enhance modularity, scalability, and maintainability. And reuse of components. The reuse of components include reuse of source codes that are developed by another developers, reuse of routines, modules, and tools that are used. The organization share the reusable components or services to achieve common goals. That means the reuse may not be from inside the organizations, but other organizations aids in our reuse. The level of reuse requires strong governance and standardization. Using multiple levels of software reuse provides various benefits, such as improved development speed and efficiency during the development, enhanced service quality and reliability, reduced development and maintenance costs, greater adaptability to changing requirements, increased competitiveness in the market. These features aid the developers and a company to build a successful and strong software that satisfies their customers. Next, approaches that support the software reuse. Some of the important approaches are: first, architectural patterns. Architectural patterns is like blueprint of a building software that shows the overall structure, collection of components in it, and how they interact with one another while hiding the implementation. Generally, it's like the abstraction. This approach helps the development team to clearly communicate the software and how it is going to be built as per the requirements of the customer. Some of the important patterns Artificial patterns are layered pattern, client server pattern, master server pattern, pipe filter pattern, broker pattern, peer-to-peer pattern, event bus pattern, and model view controller pattern. Next, design patterns. Design patterns are typically solutions to common problems in software design. Each pattern is like blueprint that you can customize to solve a particular design problem in your code. The generic abstractions that occur across the applications are represented as design patterns, showing the abstract and concrete objects and interactions. The important categories of design patterns are creational design patterns, structural design patterns, behavioral design patterns. Next, application framework. The application frameworks are subsystems designed made up of collection of abstract and concrete classes and the interfaces between them. Collections of abstract and concrete classes are adapted and extended to create application systems. The example for this application framework is Microsoft Foundation class. It is a widely used application framework for general purpose Windows applications. Next, component-based development. The component-based development is defined as a set of reusable techniques, tools, technologies that allow application development organizations to go through the AD process, that is application development process. Systems are developed by integrating components, that is collection of objects that conform the component model standards. Some of the other approaches are legacy system wrapping, service-oriented systems, ERP system. While the software reuse offers many advantages, it also comes with challenges like compatibility and versioning issues, intellectual property and licensing concerns, the overhead of maintaining reusable components, balancing customization of the reuse. Tools used in reuse. The general tools that are used for reuse purposes are repositories, analysis tools, documentation tools. Repositories are like storages that are used by a company to store their future reusable components. Architectures, design patterns, components, and codes are stored in repositories. Next, analysis tools. In analysis tools, the test data, maintenance data, changes data, and reuse data of previously developed softwares are stored. And documentation tools. In documentation tools, codes, packages, classes, subclass, routines, subroutines are stored. A real-world example of software reuse can be seen in the use of open source libraries and frameworks in the web development. Imagine a software development company tasked with building a new e-commerce website for a client. Now, the reusable components can be databases, frameworks, authentication pages, security measures, and payment processes. The developer team may not be able to build a new database again, but they can reuse a previously open source databases. Also, front-end and back-end frameworks can be taken from previous softwares. Authentication pages can be copied directly. Security measures can be implemented through libraries. And payment process will be same in every software that is developed. In this scenario, software reuse occurs at multiple levels. Reusing open source RDBMS, web frameworks, and front-end libraries, integrated third-party authentication payment processing services, leveraging established CMS platforms. By embracing software reuse in these ways, the development team saves a lot of time and effort. Benefits from well-tested and optimized solutions can aid in time reduction and can focus on building the specific features and functionality required for the e-commerce website. This approach not only accelerates development but also helps to ensure the robust and reliable end product. Since we are reusing the previous components, we'll have so much saved time and effort regarding uh, planning, designs, preparing the components, building them, and maintenance. In conclusion, software reuse is a powerful strategy that spans multiple levels. The choice of reuse level depend on the project needs, scalability, and complexity. Leveraging software reuse effectively can lead to more efficient, cost-effective, and innovative software developments. Embracing software reuse is not only a good practice but a strategic advantage in today's competitive software industry for reliable product and satisfying the customer. Thank you. N. Pranit Kumar Reddy signing out.